Well, thanks KR for this award, which we very much appreciate. You can see the pictures of all the authors below, both back in '92 and today in 2020. And the question is, I guess, have we also stood the test of time? Why did we start working on this? Well, Pat Hayes had been my PhD supervisor, and I'd become interested in spatial reasoning as a result of his work on ray physics. Dave Randell joined me as my PhD student from Cambridge in 1986, and he also became interested in the same things. As part of his PhD, he then looked in the literature, particularly in the philosophical logic literature, at spatial theories which embodied solid bodies and primitive spatial entities rather than points as spatial entities. So to begin with, these were mereological theories of parthood dating back to Laguna in 1922 through to Tarski in 1956. And then some topological theories which combine mereology with topological notions. In particular, a couple of papers by Bowman and Clark in 1981 and 1985 in the Notre Dame Journal of Formal Logic. And these led directly onto our KR89 paper in Toronto, the very first KR, and Randall's PhD in 1991. In this theory, regions, we could distinguish their boundaries, so they could be open or closed or semi-open/closed. And we ended up with a theory with 9 jointly exhaustive and pairwise disjoint relationships. In the KR92 paper, because we were interested in naive physics and we thought that was too much complexity to be able to distinguish boundaries which we didn't see the point of in a naive physical theory of space, so we defined this new theory which only had 8 relationships and eliminated that distinction. All defined from the same CXY, X is connected to Y, primitive relationship, and all done in first order predicate calculus. So you see the depiction of the relations at the top right there, disconnected, externally connected, various notions of parthood, partial overlap, and equality. Here are the definitions in first order predicate calculus, all from that CXY relationship. The red arrows in that diagram at the top indicate the conceptual neighborhood, or as we called it at the time, the continuity network, indicating what the next relationship would be if regions continuously deformed or translated in space. By the way, these are 2D visualization, but the spatial theory can also be just as appropriate in other dimensions, providing all the regions are the same. Just like Alan in his interval algebra, we came up with a composition table, or a transitivity table it's sometimes called. We did talk about a discrete version. The version we had was in continuous space, and we thought about various possibilities of how to do that. We also axiomatized Boolean operators, sum, complement, difference. We defined how to use those then to build a notion, define a notion of whether a region is one piece or self-connected. And we also axiomatized another relationship, convex hull, and that enabled us to distinguish configurations such as you see at the bottom right of this slide. I'll briefly talk about where the name RCC came from, as this spatial logic is nowadays known. We didn't invent that term. Galton in Ichkai 93 seemed to be the first person to use it, just as an abbreviation for our initials, Randell, Swee, and Cohn, but he didn't actually invent that term. That seemed to come a year later by Nick Gott's postdoc of mine. Galton subsequently in 95 suggested that RCC could stand for the regional connection calculus, suggesting that it was a mild joke because regional means an area of the country, especially one that has a particular characteristic as known for something. And we came from Leeds, but it's the former version that seems to have stuck. So what happened next? Well, to begin with, not too much, but then after about 8 or so years, the citations started to pick up, as you can see on the Google Scholar graph at the top here. A lot of the work was based on looking at RCC8 now not as a first order theory, but rather as a constraint language, and looking then for maximal tractable subsets, or to eliminate redundant constraints. There were reformulations, not in first order predicate calculus, but in relation algebra, intuitionistic logic, modal logic. There was work done on realizations in 3D and also 2D, drawing pictures from qualitative symbolic representations to actually get a picture of the particular database of relations. People worked on many extensions and modifications of RCC, a discrete version with atomic regions, which had already started to look at in the KR92 paper, a version which combined that with a continuous, the generalized region connection algebra, various fuzzy RCCs. We extended the work on convex hull to come up with a calculus with 23 JEPD relationships. We came up with an extension where we had the 8-egg yolk calculus, which in one version came out with 46 JEPD relationships and allowed us to talk about regions with indeterminate boundaries. There were other extensions, as you can see here as well, for example, the occlusion and line of sight calculi. Now Fidel looked at the cognitive validity of the RCC8 relationships. Are these relations which intuitively correspond to human intuitions? Yes, they do. Various applications in medical imaging, activity analysis is something we've done a lot of work at in Leeds using RCC8 amongst other qualitative spatial calculi to learn event definitions from video. It's incorporated in part of the OGC GeoSparkle standard. It's implemented in many reasons, including Psych, a toolkit from Bremen called Spark, a toolkit we've built for vision work called QSR Lib at Leeds, and some other partners, description logic reason in Pellet Spatial, Snark from SOI, amongst others. And there's other applications too. So in conclusion, thanks again to KR for this award and for recognizing perhaps not just the paper, but the whole field of QSR, and also all those we've discussed QSR and RCC with over the years. Thank you.